Soil improvement through vibro replacement and vibro compaction is a method for stabilizing poor soil for construction activities. While the method has only been accepted for use in the United States since the 1970s, it's a viable option to be used on a variety of projects. The following presentation will compare two methods along with the benefits of each application, known as vibro replacement and vibro compaction. With the awareness of environmental issues and availability of desired construction sites decreasing every day, the need to utilize poor construction sites is on the rise. Ground modification techniques allow engineers to extend the performance of poor soil areas and make them usable for construction projects through vibro densification techniques. Vibro densification is a relatively new technique that has gone through significant improvements over the last 40 years. The following presentation will discuss procedures, applications, design restraints of two methods known as vibro compaction and vibro replacement. Vibro densification was discovered by two Russian engineers named Sergei Steverman and Wilhelm Degen, where they developed the idea of compacting cohesionless soils above and below the water table. The method that the two decided to use was based around how to achieve effective compaction. They discovered that the way to achieve effective compaction is to place the vibratory equipment into soil where compaction will be required. The effect of placing the equipment directly in the soil allows for the emitting of its horizontal vibratory forces on the soil. The use of stone columns and reinforcements are only used when the soil does not have the capability of densifying, which leads to the process of densification. This process involves removing the volume of the soil that is occupied by voids by increasing the density. To start the densification process, a force is applied to the soil particles must be greater than the interparticle shear resistance force, which makes it possible to reach an upper particle size limit that is suitable for intended use. Densification is a 5-step process: preparation, charging, penetration, compaction, and finishing. Both densification processes use the same equipment, the vibrofloat. The machine simultaneously compacts the gravel that is poured in the hole while flushing it with water to remove foreign, less stable soil. During the entire process, power required to compact is recorded to access uniformity and size of finished column. The piece of equipment is hung from an on-site crane and is supplied gravel through a front-end loader. The first method discussed in this presentation for densifying soil will be vibro replacement. Vibro replacement is a method used to achieve vibro densification when the soil contains more than 25% fines by weight. This is achieved by the in situ soil being removed and replaced by a granular material, and therefore giving rise to the name stone columns. Stone columns are commonly used when the soil on the site is soft, normally consolidated compressible clays, thin peat layers, saturated silts, and all laminated alluvial soils. The process followed to merit a stone column is the ability to adapt itself to a load so that a collapse is prevented. Stone columns are very efficient and effective measures to prevent foundation failures. However, settlements can still be large. In respect to settling, stone columns are best used when the settlement of the foundation is within the tolerance limit of a structural settlement. Stone columns have the ability to reduce settlement by over 40% when compared to other areas that have been untreated. Settlement is restrained through lateral pressure exerted from the surrounding soil. The response of the enlargement of the stone column reaches the foundation and creates a vertical deflection. For stone columns to develop load resistance, the stone subgrade must deform vertically. While stone columns will reduce settlement, their use will not eliminate deformation. When stone columns are used in structures that require small settlements, it is assumed that the stone column will carry the entire load. This approach is very conservative and is known to approach a stone column maximum capacity, and an increased share of the total load is carried by the surrounding soil. Finally, vibro compaction is another method that we will discuss that has the ability of densifying soils in the vibro densification process. Vibro compaction is a technique that uses in situ material or borrows material with similar characteristics as the material in situ at the construction site. Through soil mechanics, the use of deep vibration treatment will result in soil improvement of geotechnical characteristics important in foundation engineering. The characteristics that vibrocompaction has the ability to improve are in situ density, angle of internal friction, and elastic modulus. Vibrocompaction allows the soil parameters to improve and is possible to increase the bearing capacity in order to reduce settlement under structural loads. Vibrocompaction is the treatment performed on non-cohesive granular soils. The technique is quite simple as it relies on the fact that intergranular forces between cohesionless soils can be overcome by the effects of vibration. The soil grains are then rearranged under the forces of gravity where they achieve the maximum allowable compactness. The vibration method allows for the void ratio in the soil to decrease. The decrease in this ratio increases settlements in the above soil layers. The process is then repeated until the vibrofill reaches the surface. The method of vibrocompaction is best used with soils that are clean and cohesionless. Research has shown that when the percentage of fines by weight exceeds 25%, the process is ineffective. All structures will be designed to support with the minimum differential settlements, and most structural engineers agree that they are designed to withstand a quarter of an inch of differential settlement and remain unaffected. Due to their reasoning, the effect of using vibrocompaction methods on job sites allow for the use of low-cost foundations and achieve a more economic product. The depth of treatment for vibrocompaction assumes elastic stress distribution patterns. The significant influence of stress on the surrounding soils may not affect soils at depths greater than twice the width of the foundation design. The area of treatment lies entirely within one soil layer and never penetrates underlying stronger materials. This is caused by the densification and strengthening of the overlapping homogeneous layer. When soil reports show that a soil layer is strong enough to support the proposed loads, it is not necessary to treat at depths beyond this layer. Vibro replacement and vibrocompaction are both methods for modifying unsuitable soils to be able to support a conventional structure. The techniques described have gone through decades of research and refinement and are now viable options when designing deep foundations in unstable soil. Vibrocompaction and vibroinsertion will be a viable technique for a long time and will continue to be a viable alternative to deep foundation design. With the amount of infrastructure and other buildings on the rise, the need for suitable land is on the rise as well. These techniques allow for unsuitable land to become large products that are both safe and economical.